So what will be the size of the audience that you're expecting?
Maybe around 200. That's what I'm
Good.
expecting right now.
Okay,
It may go up also.
I see. Oh, it's streaming on YouTube also?
Yes, YouTube also. YouTube Live is also there. Both.
Oh, I see.
Just please make Professor Vital Rao as the co-host.
Done, sir.
Yeah, and
Yes, sir.
for me also, still I'm not getting this share screen permission for the other account. So I'm logged in from 2 accounts, so I need share screen permission for both the accounts.
Vital Rao sir, you can unmute now.
Yes, sir. Good morning.
Good morning, sir. How are you?
Fine. How are you?
Yes,
So
so
nice.
happy
I'm waiting
to.
for the lecture.
Yeah. Sambit sir, we have Professor Vital Rao, former professor of IISc.
Hello, sir. How are you?
Hello, sir. Good morning.
I'm doing good morning. I'm doing
Good
well.
morning. Good morning. Yes. I'm waiting for your lecture eagerly.
Thank you so much.
You was my teacher at IISc.
Oh, so nice. So nice.
Yeah, one of the best teachers in mathematics in the last several years.
Oh, very nice. Very nice.
And
Very nice.
possibly the in the top 5 as the applied mathematics is concerned.
Oh, so nice. So nice.
And I think his lectures are all popular. I think one of the best teachers that we have ever had in mathematics.
Very nice, sir. Very nice.
Thank you, sir.
Yeah. This whole artificial intelligence is based upon very strong foundation of mathematics.
Yeah, I know. I know.
So it will be nice to get your perspective someday. What we should do.
I am a mathematics man. I know very little about artificial intelligence. Yeah, I know. I mean, of course, the nice thing in IASC is the students are good. We have very little to do.
I see. My favorite boss or manager, Daman Hejmadi.
He was my student.
Yeah, he was my boss, and he's a very good friend, very dear friend.
Oh,
So,
he was my student actually.
Yeah,
I know Daman.
Yeah, so he's from
Is he still with Intel?
No, he left around 4 months back.
Oh, I see.
So we worked together in Qualcomm, where he was my manager, and
I see.
So
Yeah, I remember him very well. Yeah.
I see.
Yeah, that was way back, maybe in the 80s. He was a student.
Yeah. He's a very bright individual, very good leader.
Yeah.
Very visionary.
So where is your office now?
In Outer Ring Road.
Okay.
Yeah. We have the big Intel campus there.
Yeah. But most of you work from home, or?
Yes, we do work from home, and my team also is worldwide in India, US, Malaysia. So try to connect with each other and trying our best. Yeah.
Difficult times.
Yes, sir. Difficult times. But we are managing it somehow.
Yeah.
We're managing it.
Yeah. See, that's the beauty about human beings. They adapt quickly and.
Yes. And I think these technologies are helping. Even this Zoom call, everything is being helped.
Yeah. Otherwise, it would have been disastrous, actually.
Yes, sir. Bital sir,
Even-
do you still teach these days?
Yes and no, in the sense that I'm still associated with the institute in a very informal manner.
Right.
I do teach,
Right.
but this year, due to all this
Yeah.
mess, I opted out from teaching because I'm still not very comfortable with all this tech teaching and all. But I still teach. I do give lectures on the Zoom and other platforms.
Very nice.
Yeah. But it's long since I retired.
Sure. Very nice.
Nothing like you're teaching on the blackboard, sir.
Yeah, yeah.
Even today, students love it.
Yeah.
Even now, what I do is when I use my iPad, I switch to the night mode and keep the screen black and write with the white pencil.
Yeah.
Recently, I had organized one lecture by Professor K.G. Rangaraju,
Mhm.
and he clearly said he's going to use only blackboard for teaching.
Okay.
I organized over 3 lectures by Professor Rangaraju in fluid mechanics.
Okay.
Went to the class and taught for 3 hours, 1.5 hours each. All the students came back and said, please throw everything out, sir. Please get the teacher in. We want only blackboard teaching, that teacher only.
Yeah, I mean that makes it makes a lot of difference even for the teacher. You see the feedback he gets instantly by looking at the face of the students. It's very important.
Yeah. Bital sir, when things open up, it will be our honor and privilege if you can share a few things with me and my team on
Great,
how.
sir.
Yeah.
Yeah, I'll try my best. Yeah, sure.
Thank you, sir. Thank you.
We will start, Sanjay sir. Let others join.
Yes, sir, we can start.
Yeah, because others let them join.
Yeah, sure, sir.
We'll start the.
Sure, sir.
Sambit sir, we'll start.
Yes.
Yeah.
Yes.
Good morning. It gives me immense pleasure to welcome Sambit Sahu to deliver the commemorative lecture on the occasion of the 20th anniversary of BITES, the Board for IT Education Standards. And also extend warm welcome to Professor Vittal Rao, the faculty and students from BITES member institutions. Also extend a warm welcome to the board members of BITES and several invitees and the faculty, colleagues and students from Dayanand Sagar group of institutions. Let me set the context for this particular lecture and briefly tell you about BITES and also introduce the speaker of the day very briefly. This is the commemorative lecture on the occasion of the 20th anniversary of BITES. This lecture is being delivered by Ms. Sambit Sahu. The title of the lecture is Intelligent Edge, Confluence of 3 Emerging Technologies, the IOT, the Artificial Intelligence, and 5G. This lecture is coming to you in collaboration with Intel India Leadership and Excellence in Academic Development Program, LEAD program, hosted by Dayanand Sagar Group of Institutions. As you're aware, BITES, Board for IT Education Standards, started in the year 2000 with the objective of improving the quality and standards of IT education and also improve the employability of IT graduates. Bytes has been doing lots of activities in this direction. And one specialty of Bytes is that it's bringing all the programs to the students and the faculty and the managements of Bytes member institutions, which are relevant and useful. Of course, without charging anything, any fee to any of the members. And this particular lecture we have been looking forward to this lecture, and we are happy that Sambit Sahu could accommodate this lecture in his busy schedules, and extremely thankful to him for accommodating this, and also thankful to Mr. Sumit Verma, who has helped us to connect to Sambit Sahu. Let me briefly introduce Sambit Sahu. Sambit Sahu is Vice President of IOT Group and General Manager of High Velocity Silicon and Platform Engineering Group across the globe at Intel Corporation. Based in Bangalore, he leads product design and development operations, Internet of Things market segments, with a focus on promoting excellence in system on chip, that's SoC, and platform design. With over 20 years of experience in semiconductor industry, Sahu has held a number of technical and management leadership positions in multiple areas of SoC design. Throughout his career, he has led teams delivering dozens of products in various market segments, including smartphones, modems, IoT devices, small cell products, and intelligent routers. Before joining Intel in 2016, Sahu spent 4 years at Qualcomm Incorporation, culminating in his role as Vice President of Engineering at Qualcomm's Bangalore Division's Design Center. Earlier in his career, Sahu spent 13 years working in the United States, where he served in senior technical staff roles at Sun Microsystems, Crockett Networks. He started his career in 1982 at Intel, spending his first 8 years with the company as technical lead and manager in intellectual property development and electronic design automation tools. Sahu has earned a bachelor's degree in electronics and telecommunication from University College of Engineering, Burla, India, and a master's in computer science engineering from University of Louisiana at Lafayette. Sahu sir, we are so happy to have you and welcome to this particular program, and I request you to take over and deliver the talk on intelligent edge, which we have been awaiting for from a long time. Over to you.
We do several products on IoT, AI. Thank you, Professor Murthy, for the kind introduction. Hello, everybody. I'm Sambit Sahu. Good morning to all of you. I lead the IoT engineering group in Intel. I and my team, we do several products on IoT, AI, computer vision, and similar such things. I hope all of you are doing well. I hope all of you are staying safe and healthy. First of all, big congratulations to Bytes for their 20-year anniversary. I'm really very privileged and honored to be part of this wonderful occasion. I wish I were live with you and talking to you, but due to this COVID-19 pandemic, we have to do this virtually. I would also like to thank Dayananda Sagar University for hosting this session. What I'm going to talk to you today is about a big revolution happening as we speak. Three main technologies: 5G, which is a next generation wireless protocol technology; IoT, which stands for Internet of Things; and AI, which stands for artificial intelligence. All three are coming together to build a very significant revolution. I personally, in my 30 years of my career, have been through many such technology revolutions. But this one, as I see, is by far the best and the biggest. Many companies, many universities, many countries are all coming together and all contributing and all building products and technologies as part of this revolution. And next few slides, I'll share with you my perspectives on it. Just want to share a legal disclaimer from Intel. The agenda that I'm going to cover, first of all, what's the motivation, what's happening and why it is happening. Then I'll introduce you three concepts. You may have read already about them, introduce them: IoT, AI, and 5G. Then I will share with you how these three technologies coming together, what I call as the confluence, to build a wonderful thing called the intelligent edge. And then I'll share with you what is the importance of this confluence, what are the benefits. I'll also give you some idea what are the technologies behind this confluence. And then I'll share with you about who are the players and how is Intel India playing a role in it. And then I'll talk to you about some of the future trends. Now, before I go through details of my presentation, I would like to share with you just a very short video to give an idea on exactly what is happening.
Outcomes matter more than ever, but where do you start? Before efficient logistics at sea, there's a deep dive into analytics. Before unlocking the secrets of the brain, there's a trained neural network. Before flawless tires hit the open road, there's AI-assisted quality control. Before a voice can be heard, there's text-to-speech translation. Before early-stage detection, there's AI-assisted imaging. Before your next great outcome, all you need is an idea and Intel inside. Harness the full power of your data through accelerated AI and analytics with our most versatile cloud-to-edge portfolio. Start here.
Okay, so hopefully that gave you a glimpse on what I'm going to talk about AI, about neural networks, about connected world, okay? And that's what is happening right now. So as I see the world, where is it moving towards? It's moving towards a very well-connected world, like billions of devices, all need to be connected with each other. A very smart world, all these devices need to be smart and intelligent. And also a lot of interactions. Interactions, how do we interact between humans? How humans interact with machines or devices? And how these machines and devices also interact with each other. lot of focus on security and privacy. How do we make sure that we make our lives secured? How do we make our products secured? Quality of service. I mean, you may have heard about user experience. So the world is moving towards a great user experience. And then quick response and action. Because most of the applications today, they need very quick response. And I'll just give an example. Let's start with our home. You know, these days people call a smart home. Okay, and let's see what's our smart home. How is it emerging? If you look at it in terms of connectivity, today I can control my lighting system with my smartphone. So basically, all my lights in my house I can control through my smartphone. Okay. My smartphone can connect to a TV and stream video to the TV. So this is how things are getting connected. How it is intelligent, how things are intelligent. Today I can install smart cameras around my house and detect any intruders. I can also install a biometric system in my house which can recognize my face. How about interactions between human to machine and machine to machine? So today, you know, we have a lot of appliances in our house, like refrigerator, TVs, washer, dryer. We also have to make sure that house is protected against any fire hazard. So there are fire hazard systems. So if there is any risk or danger to any of the appliances, that appliance will immediately send a signal to my fire hazard system, which is another appliance. And the fire hazard system will immediately respond and react and try to douse the fire or eliminate the danger of a potential fire. Even today, we are evolving human robots. We are evolving robots for home. Very soon we'll find robots in a home. So there is that human to robot, which is a machine interaction. Security and privacy. We have to make sure we make our home secured. We have to make a home secured against any intruders through smart camera system. We have to make sure we secure our computing and our technology assets at home through different technologies. We have to secure our home for any hazards like fire hazards, electrical hazards. So multiple security aspects popping up in home. And privacy. My home is connected to the internet. I am sending and receiving data over the internet. I don't want my data to be shared with others. So a lot of technology is also evolving. How do we protect a user privacy? And quality of service. I should be able to control my home. I should be able to operate on my home very seamlessly. I should be able to control and modulate the devices in my home while I'm at home, while I'm in my home, also while I'm outside. I should be able to control things remotely. And quick response and action. As I said, if I have a potential fire hazard in my house, I want my fire hazard system to detect that very quickly and respond very quickly so that the fire hazard can be eliminated. So, as you see, the world is moving towards a very well-connected world, a smart world with lots of machine-to-machine, human-to-machine interactions, which needs to be secured, privacy has to be respected, user experience has to be excellent, and mission-critical activities have to be done very fast, very quick. Now, you can scale this concept of smart home to a smart community, smart city, smart country, smart industry, smart transportation. this is where and how the world is evolving, or I would say we are in the brink of a major revolution, and let's all ride on it. And I will also say that many companies in India, like Intel, Qualcomm, Nvidia, Google, Amazon, many engineers working in these companies in India are playing a huge role in bringing this revolution to success. I just want to share with you, okay, the technologies, the applications are wonderful. What's the business value? As per ABI research, it's a market research, very prominent market research company. As per them, by 2035, this AI and 5G will enable a $17 trillion economy worldwide. $17 trillion. That is $17,000 billion. And the major ramp will happen 2025 and onwards. Because from now till 2025, we'll spend a lot of time in establishing the infrastructure, in making our technologies robust, and after 2025, this will shoot up, and by 2035, the world will see a $17 trillion economy generated by all these technologies. This is just too huge. So I'll just introduce just few concepts. IoT, which stands for Internet of Things. A IoT device does some computation, does some useful thing for the user, is connected to the internet, it sends and receives data to the internet. That's the fundamental of definition of an IoT. Your simple wearable that like you have, let's say, Apple Watch, that's an IoT. It does a lot of useful things for you. It sends data on the internet. You can receive it in your smartphone or other devices. So that's an IoT. Your smart TV, these days we get smart TVs. Your smart TV is also an IoT. It's connected to the internet, and you can get a lot of excellent streaming services from Netflix and Amazon Prime. So that's another IoT. You may have heard about drones. That's also an IoT. Drones are basically automated kind of robots which can fly and collect data, collect intelligence. They have camera systems. They are also connected to the internet. They send and receive data through the internet. So these are all examples of IoT. And there are predictions that by 2025, 70% of the devices in the world will be IoT devices, which can do some computation, which does some useful things for you, and which are connected to the internet. So 70% of the devices worldwide will be IoT devices. Now, what's AI or artificial intelligence? AI is nothing but making the machines intelligent, making the machines adopt the intelligence of human beings. And this AI is evolving very rapidly. And machine learning and deep learning are contained within this AI. Machine learning is a subset of AI, and deep learning is a subset of machine learning. And the machine learning and deep learning they're going to be very useful to develop the motivation that I spoke about. Let's start with a simple example. Let's say I have a lot of pictures and I want to segregate a human being from a dog from the pictures. I can write a very simple program to do some basic things, or I can use some machine learning techniques. I can extract some features from those pictures. For example, a dog has two legs. A dog has four legs, but a human being has two legs. A dog has a tail. Human being doesn't have a tail. A dog has a snout, but a human being don't have a snout. So using those features, I can guide my computer to segregate a dog from a human being. Now, if I go deeper into deep learning, I can do the same job, but I don't need to define any features. I don't need to tell the machine that a dog has a tail but a human being doesn't have, or a dog has four legs but human beings have two legs. I don't have to tell the machine that. The machine will be intelligent, the machine will be smart, just looking at the images to go and segregate that this is a human being versus this is a dog. Now, this deep learning is becoming a foundation of a lot of artificial intelligence. And this deep learning is giving rise to a concept called neural networks. And I'll talk about that. Now, artificial intelligence, there are different aspects to the artificial intelligence. There are different applications of this artificial intelligence. The computer vision I talked about, like from a set of pictures, the computer can distinguish a dog from a human being or a dog from a cat. So a lot of image recognition, machine vision happening to do that. You may have used voice assistants like Amazon Alexa or Apple Siri, where you tell those voice assistants to play some song or to get the news for you, and those voice assistants will go and get that information from you for you. Lots of things happening in text to speech, When you write a text, how that can be converted to a speech, or when you give a speech, how that can be converted to text. Lots of things developing in expert systems. How do we diagnose our medical imaging better? Lots of development happening in robotics. You may have heard about robotic surgery. I feel that in the future, robots will be everywhere. Robots will be in hospitals, robots will be in department stores, robots will be at homes, robots will be everywhere. So this whole artificial intelligence is triggering so much of applications where our lives can be much more effective, much more productive. And this artificial intelligence, as I said, these applications, the foundation of it is deep learning, a neural network. Now, what's a neural network? The neural network has been compared to a human brain. A human brain has lots of neurons, which does some processing. And those neurons are connected to each other through synapses. In a human brain, there are around 200 billion neurons, 32 trillion interconnections. And the intelligent processing by the human brain can be done very fast and can be done with very low power. So here with neural networks, we are trying to mimic the human brain. It's not easy. It is evolving, but that's the attempt. Just like you have neurons in your human brains, we are also building neurons in our computers. And these neurons will be connected to each other. And these neurons will have some weight, some activation functions. They are based upon a very solid mathematical and statistical techniques. They're based on a foundation of algorithms, but the whole objective is to build these neurons and interconnection in the computer to come close to the brain. That's the whole idea. And the neural network is built out of these neurons, is built out of layers of neurons. And each layer has many neurons. And these neural networks is the foundation of deep learning, and deep learning is the foundation of artificial intelligence. The next concept is 5G. 5G is the next generation wireless protocols. If you look at your smartphones today, largely it is 3G or 4G. G stands for generation. 5G just coming in. The recent Apple iPhone 12 is equipped with 5G. Now, the big advantage of 5G over its previous generations is that it gives 10 to 100x better bandwidth, better throughput, better latency, better density, better power. Pretty much it's a significant order of magnitude better than the previous generation. And we need this technology as we connect these billions of devices, and we need this technology to make our devices smart. So there are three, all the 5G applications are contained in this triangle with three vertices. One is enhanced mobile background. Basically, how do we increase the throughput? How do we increase the bandwidth? For example, we need a lot of 4K or 8K videos available to us very fast. So enhanced mobile background enables that. Second is ultra reliable low latency applications for mission critical applications. For example, in driverless cars, we are all talking about driverless cars these days. For driverless cars to operate safely and effectively in the roads, they have to rely on smart technologies and very quick processing. Otherwise, there will be serious accidents. So this low latency communication enables the driverless car to communicate and receive responses from its surroundings, from other cars, from other obstacles, from traffic signals. It needs quick response, faster, very fast response, in the orders of milliseconds. And also to be very reliable. It has to be effective 99.99% of the time. Otherwise, there will be catastrophes. And the third piece of this 5G is massive machine-type communication. If you have to connect billions of devices and give them the desired quality of services, whether in a smart home, smart city, smart community, The technology has to provide sufficient density, has to support sufficient density of these devices getting interconnected. So gigabits of bandwidth or throughputs, milliseconds of latency, 99.9% of reliability, and connecting millions of devices in a square kilometer or a square mile to provide the quality of service. All these are becoming pillars of 5G. And 5G is the technology that enables all these things. So you have IoT, which your device does something and connect to the internet. You have AI, which are how do we make our machines smart and intelligent, and you have 5G, how devices talk to each other very fast with a lot of bandwidth, a lot of throughput. And all these three things are coming together. Confluence of these three technologies is what I call as the intelligent edge. Okay, so I'll talk to you a little bit about the architecture of this intelligent edge. Traditionally, we have our end devices like we have wearables, we have smartphones, or we have personal computers. And traditionally, they connect to a cloud. A cloud is basically a massive amount of computation and storage, which is available somewhere in the world, in a data center somewhere in the world. And my smartphones or wearable or my personal computers, they are connected to this cloud. They're in constant communication with this cloud. You may have seen in iPhones, you have iPhone and then you have iCloud. So any significant processing you want to do, and if the iPhone is not sufficient, it doesn't have sufficient computation power, then the iPhone sends the data, sends the process to the iCloud where it gets processed, and we get the results back again to the iPhone. So that's the traditional, I would say, end device cloud architecture. But what we are noticing in this evolving world, in the motivation I spoke about, that is not sufficient. There are many reasons why it is not sufficient. The most important reason is mission critical application. If I have a driverless car, and the driverless car is operating the road, then it has to process data very quickly. It cannot send data to a cloud which is in the other side of the world, wait for the processing to get over and get the results back. By that time, some catastrophe would have happened and some major accident would have happened. So it is becoming important that we need something where the processing, where the computation can be done closer to the driverless car. That's number one. Second is, it has to be scalable. If we have billions of devices connected to each other in a smart community or a smart city, and they need their personalized services, they need their location aware services, they need their personal contact services. The traditional cloud architecture may not scale up. We need some computation closer to the smart home or smart city to provide their personalized services, to provide the density of the services. Number three, our end devices are largely battery operated. Whether it's a wearable or a smartphone, they're battery operated devices. And they are also limited in their computational power. And particularly with neural networks where we need lots and lots of computation, these devices may not be good enough. So they have to offload some of their serious processing, serious computation to somewhere close by. So all these things, whether it is mission critical, fast latency, high density, or offloading computation, we need something closer to our devices, does some of the similar things that the cloud does, and that's what is called the intelligent edge. And that's the middle layer, as you see. That middle layer intelligent edge, it brings in some of the cloud capabilities, not the whole thing. We don't want to mimic the entire cloud, it's very expensive. But some of the cloud capabilities, we want to bring it to the end user, closer to the end device. So some of the characteristics of this intelligent edge, they're close to the end user, they're close to the end device. They're at the edge of the network, number one. Number two, they need to have massive amount of processing and storage capability to do all the smart processing, the deep learning processing, the neural network processing. Number three, they need to orchestrate things between cloud and the end device, which means they need to mimic some of the functionalities in the cloud, and they have to offload some of the computation from the end device. And number four, because it's a big ecosystem, many players are building technologies for this ecosystem. This intelligent edge has to orchestrate, has to utilize all these technologies very effectively. And the benefits, as I talked about, whether it's for mission critical applications, of computation from the end device, improving security, reducing cost of your transmission, putting lower pressure on bandwidth, highly reliable, increased availability are all benefits of this intelligent edge. So this intelligent edge, along with our end devices, are evolving very fast. So just to give you a different view of the picture, if you look at the right side, these are all IoT devices. They're all interconnected with each other through 5G to enable what I call as a device-to-device communication. And they're all getting smarter every day. And all these devices are connected to an edge gateway, which does most of the processing, big processing for them, and which also coordinates activities with the cloud. And this edge gateway is connected to your IoT device with 5G on one side, and connected to the cloud also with 5G on the other side. So the world is moving towards all these things are connected to 5G. And your intelligence is built into all these things. Your end devices have small amount of computation. Your edge device has medium amount of computation. Your cloud has, because just the sheer amount of computers and storage able to the cloud. has the ability to process large amount of intelligent computation. So they are all interconnected through 5G, and they're all intelligent. It's just the degrees of computation that they have available for this intelligent processing. This is where the world is moving towards. And just to give an idea about how this is transferred to applications, if you look at your online education, which is becoming pretty important due to this COVID-19 pandemic, how do we enable remote learning? How do you enable interactive learning? How do you monitor the students in a classroom? How do you have a very immersive learning? So this all this confluence and all this intelligent and connected world is making a big impact on our education. Same thing with our health systems. How do you diagnose things very reliably? How do you use machines to help doctors in better diagnosis? And as I talked about robotic surgery, that is picking up. We also look at retail. How do we get a very immersive experience while shopping? The department stores in my locality has the intelligence of my shopping experience and can recommend me the right kind of items or the items that I will be interested in. Even inventory management and robots managing the shop floor, all these things are emerging. A lot of things emerging in airports, in hotels, in restaurants, to get a better user experience, to get a smarter experience to the user. So many applications in every part of life, every aspect of life is evolving, is growing, and all moving towards a connected, intelligent world which should be secure and reliable and deliver a wonderful user experience. Now, what are the different type of products in this intelligent edge? It starts with basic products called sensors. For example, in my iWatch, I have a lot of sensors in my iWatch which measures my temperature, my heart rate, my blood pressure. So these are sensors. All the sensor data is aggregated into some device which I call raw data processors, like my watch or my smartphone or my smart TV. I would say these are called aggregators. The third is cloudlet. Cloudlet is which can provide that intelligent edge for a small set of users, maybe a home, maybe few homes. Then the next one is MEC or multi-access edge computing. These are intelligent edge products that are installed at the base stations. They can intelligently manage the networking, the spectrum available, the content delivery systems. They can manage that. And then you have fog computing, which is a bigger scale of cloudlet, which have more powerful computers, more numbers of computers, serving, let's say, a smart community or serving a smart city. So starts with sensors, very small sensors, then goes to aggregators, then goes to cloudlet, the networking, and then the fog. Now, what are the technologies behind it? I would say today, pretty much almost all companies, technology companies, are somewhere or other involved in this Confluence. Whether you talk about the hardware players like Intel, NVIDIA, AMD, Qualcomm, or you talk about uh, the internet companies like the Googles, Amazon, or you talk about the software giants like the Microsofts and lots and lots of companies are involved today in building technologies and solutions for this. And there are 4 areas of technologies. One is in silicon. A lot of silicon players like the Intels and NVIDIAs and AMDs, they're developing new kinds of silicon to cater to this connectivity, intelligent, smart, secured world. So things are coming in the forms of CPU, GPU, which stands for graphical processing units, FPGAs, which stands for field programmable gate arrays, and custom ASICs. And these silicon come with multiple cores. This silicon can be put into multiple sockets, multiple boards. Lots of innovation happening with silicon. The silicon is also advancing towards newer technologies. Like you may have heard about TSMC, 5 nanometer, 3 nanometer, basically deep submicron technologies where the silicon are getting manufactured. Lots of innovations happening in memory because memory storage is also becoming a big bottleneck for this intelligent processing. And we have to make sure we develop or deliver the performance at low power. The brain operates at 20 watt of power. Our intelligent computers have to perform like a brain with that speed and that low power. The other big thing happening in silicon is basically disaggregation. Since we need massive amount of computation, it's not easy to build all this computation in a single chip. So we are breaking the architecture into multiple pieces, and then we can mix and match different functionalities together. We can also scale out to build bigger and bigger platforms. So lots of research or development happening in what I call as a disaggregated silicon strategy. In AI, it's growing by leaps and bounds. Every day there are new papers, new publications. New type of neural networks emerging as we understand new applications. Application developers are working round the clock to develop new applications for all your smart stuff, smart home, smart city, smart manufacturing, everything. We're also figuring out techniques on how do we process these neural networks, how do we process these trainings and inferences of, in a distributed manner, in a secured manner, maintaining the privacy. That's called federated learning or distributed learning. A lot of technology coming with networking. As you saw, 5G plays a big role in this whole thing. So how do we make sure you utilize the bandwidth properly? How do we make sure that we serve the networking needs of these end devices effectively? How do we slice a network into different pieces so that we can cater to multiple applications with different type of needs? Real time is becoming very important for mission critical applications like driverless cars. Cognitive radio is another technology which is like a smart way of utilizing any underutilized spectrum, or how to reduce the congestion in the network. So lots of research and investment happening in cognitive radio. In software systems, a lot of evolution happening. There are two concepts called virtualization and containerization, which is going to be very useful. How do we manage this whole ecosystem with so many different hardware, so many different software, different operating system, different applications? So technologies are getting built. How do we manage these heterogeneous systems? And how do we manage the different type of workloads? Like you have audio workload, video workload, real-time workload. How do you manage the different type of workloads with the right performance? And how do you provide a very secure and a private infrastructure? Just to give an idea, if I just look at this intelligent edge silicon piece only, as I said, it's evolving very fast. By 2025, this intelligent edge silicon, not the entire platform, not the entire software, just the silicon piece of it, will outpace the silicon revenue in the cloud. So today, it's a very small component. In 2020, it's a very small component. But by 2025, it'll outpace. So I'll give a little glimpse on really what is Intel doing. Intel has products pretty much end to end. On the left side, it has products in the sensor side of things, in its Movidius offering. Is what we call as smart cameras. In the edge, with the intelligent edge, it has multiple offerings in Atom, Core, i7, Xeon, different types of offerings for different type of applications. Xeon being the big powerful ones, which is used for video analytics and the intelligent processing. Then we have the accelerators, which enhance the performance of the intelligent processing. So lots of offerings there. And on the right side, data center, Intel has lots of wonderful products and has major market share in the cloud products. So Intel has end-to-end silicon and platform offerings from the endpoint to the edge to the cloud. And this is all tied together with a very good software infrastructure called OpenVINO. OpenVINO stands for Open Video Inferencing and Neural Network Optimization. That's the foundation for this intelligent edge. And of course, there are lots of other technologies I spoke about, with virtualization, containerization, security, privacy, networking functions, all embedded as part of this OpenVINO infrastructure. So, lots of engineers in Intel India working in many aspects of these products. Me and my team also own and deliver many of such products. Now I'll talk a little bit about India. India is playing a huge role. India wants to be the leaders in this digital transformation. Our Honorable Prime Minister, Mr. Narendra Modi, he wants to take India to a $5 trillion economy by 2024 or 25. And this digital transformation is going to play a huge role in that march towards $5 trillion economy. And this digital transformation is already happening. And the technologies that I spoke about, the IOT, the AI, and 5G, are the foundation of this digital transformation. They are going to be applied to retail, to manufacturing, to healthcare, to industrial, to agriculture, to transportation, every aspect of it. And many companies in India, both Indian companies as well as MNCs, are joining hands to deliver products and solutions for digital transformation. And India will also be a proof point for many such applications, for many such technologies, for many such solutions. And Intel India also is playing a huge role in this aspect. In Intel India, we have started an initiative called INAI in collaboration with IIIT in Hyderabad, Government of Telangana, Ministry of Science and Technology, and our objective are three pieces. One is, how do we build up an ecosystem in India through startups, through university engagements, through funding some research. So how do we create a platform, an incubation center for these new technologies, new research ideas, new economic growth? Second is, how do we create an infrastructure that gives back to the community by bringing in new platforms, by developing new algorithms, new tools, new data sets? We are building on things in many areas, whether it's about traffic systems, autonomous driving, smart agriculture. In many aspects, we are building up technology solutions, what I call as giving back to the community. And all these are based upon a robust governance, because privacy and security are very important. So our solutions, we are largely targeting towards healthcare and smart mobility. Just to give you an idea about the global landscape, many companies in many segments, as you see, AI companies, service providers, hyperscalers, silicon companies, networking companies, many companies are coming together to build this intelligent edge, to build this confluence of IoT, AI, and 5G. And many of these companies have their parts of their research centers in India also. So I hope I gave you a glimpse of the technologies, how these things are coming together, the benefits of these technologies. And I feel this whole revolution is going to continue and evolve for the next 30 years. So just to give you an idea about the future opportunities, because these technologies are still evolving, these solutions are still evolving. First of all, the solutions have to be very robust and has to be scalable, because we have to build smart cities, we have to build smart countries, we have to build smart industries. These are big scale. Second is how, as you saw, hardware, software, networking, all coming together. So how do we get the best out of this combination? How do we optimize between hardware, software, networking? Third is, artificial intelligence. Today, we are nowhere close to the human brain. I'm glad that we are making attempts, but we are nowhere close. There is some research happening on a subject called neuromorphism, which is to attempt how our computation can come closer to the human brain. Then 5G and beyond. While 5G has a big leap over 4G, but I'm pretty sure the wireless companies, they're looking above and beyond 5G. Lots of things need to happen in security and privacy. You may have read, you may have heard so many issues in security. There is hacking going on every day. Privacy is getting compromised. So lots of work needs to happen in security and privacy. And also ethics. Technologies are very good. They are wonderful applications. But they can be misused also. They can be abused also. So how do we make sure that we don't compromise on our ethics, on our good value system, on legalities while developing solutions? And last but not the least, you can have great infrastructure, great products, but the applications also have to evolve. The applications have to take advantage of the underlying hardware, of the underlying platforms, and make it useful for the user. Give it an excellent user experience. So lots of future opportunities. I have a video. I'll share with you one of those future opportunities in the smart industry. So I'll play maybe a 2-3 minute video. Okay. Hopefully that gave you an idea. And this whole smart industry, smart factory is happening as we speak. It's happening in auto companies like BMW and Mercedes-Benz. It's happening in industrial companies like Siemens and Bosch. It's happening in many such companies. And I would like to acknowledge the literature that I used. As I said, lots of research happening, lots of products coming up. So I would like to acknowledge the publications that I borrowed material from, the books I borrowed some information from. I utilize some of the product literature from the different companies. So I have to acknowledge, and I'm thankful to them. And with that, I conclude my talk. I'll be open to question and answer. Thanks for your patience in listening this talk. I hope it was helpful. I would really appreciate and thank BITES and Dayanand Sagar University for giving me this opportunity to come and share with you my perspectives. Thank you.
Yeah, good morning, sir.
Hello. Can you hear me, Dr. Sanjay?
Sanjay sir, could you please take over?
Yes, sir. Yeah, 1 second. I am taking over. Just 1 second. Here. Second. Yeah. Thank you, sir, very much for this very comprehensive introduction to these all key technologies. I'm sure range of people from our BITES, like from novices till experts, have really got a lot of things to learn from this. So let's go to the questions. And people have put a lot of questions in the chat box, so I will read one by one. and no, we'll
Can
get
can you
answers
hear
to them.
me?
Yes,
Sanjeev?
sir. Yes,
Okay,
sir. We can
very
hear
good.
you. Yeah. Yeah. So first question is from Karthik Pai. So hello, sir. What about various job losses on the commercial applications of these projects?
Well, a good question, by the way, a very good question, and this question comes up in many times. I have been in this technology world for the last 30 years or so, and this question comes up every time. But surprisingly, the world's needs are always more than what the technologies can deliver. You know, for example, we are going through this COVID-19 pandemic, and obviously it is definitely very unfortunate and very challenging. And scientists in the world, are trying very hard to come up with vaccine. And I'm hopeful those vaccines will come very soon, maybe the next few months. But in olden times, to develop these vaccines, and you can read in history, and is that it would have taken probably 15 to 20 years. Okay. So now with technologies and so many scientists coming together, and many of them using these AI techniques, hopefully will come with a vaccine. So the world needs more productivity. The world needs more efficiency. And I saw that with every technology, coming in, the same question came up, but the world needs were higher than what the technologies. Yeah, and some of the job situations I hear, I come to know that this whole artificial intelligence and whole IoT. Today there is a dearth of talent. Like in the next 5 years, we need probably millions of people to be working on this artificial intelligence, IoT, and make it successful.
I'm in a lecture for a few minutes after a few minutes.
Yeah. So, yeah, again, we have to, respect it. We have to respect human emotions and human needs. No question. But I'm pretty hopeful that this technology will help us even be more productive, take the world, in many ways to a better place.
Thank you, sir. Next question is also regarding some concern. It is from HOD ISC. I'm not sure which college, maybe Dayanand Sagar College of Engineering. The question is, if we use more IoT devices, what about radiation rate?
That's a great question. Actually, this is definitely a cause of concern. Even when we use smartphones, it a cause of concern. And uh, there are technologies and techniques that are getting developed or are developed, like handsets or electromagnetic shields or better antennas, things like that, which are developed or getting developed to reduce this. And also, when you install these towers, these cell towers or base station towers, we just have to make sure that you take the necessary precautions and so that you reduce the electromagnetic radiations. So that's the second thing. Third is there are government regulations and international bodies which are monitoring this and coming up with standards or recommendations. So multiple things are happening, but I won't deny that this is not a concern. It's a concern very well published, and we should see how to make it better and better. On the other hand, actually, the other thing is that this IoT has a lot of sensors, and people are researching on biodegradable sensors. So that's another thing that's also happening. So, but on the other hand, these IoT and AI things, from their intelligence, they can really monitor the environment situation, whether it is electromagnetic radiations or it is pollution or potential hazards, earthquakes, and okay, they can alert us, and we can take the necessary precautions. So there are a lot of advantages. Okay, and also, how do we do renewable energy? How do we promote greenhouse effects? How do we make smart grids that reduces the amount of power and efficient utilization of our power assets? So multiple things happening. But I won't deny that this is not a concern, and continuous research needs to happen on that.
Yeah, thank you, sir. Next question is Dr. Srinivas, our Dean of School of Engineering. Sir, any thoughts on the kind of lightweight security algorithms that are needed for the edge devices?
Well, let me be very frank. This today, security is probably one of the biggest concerns among all technology companies. Uh, there are smart people in the world, and they can hack our systems, and we hear that. And today, this is one of the biggest focus areas even in Intel, security. So lots of things are evolving in the hardware. Lots of things happening in encryption. Lots of things happening in software. Even this AI, artificial intelligence algorithms, they're getting used or developed to identify security threats coming in from the different type of users or from the different ways of communication. And yeah, so AI can detect threats and at least alert the user or the company on potential threats. So this is a very well researched area, lots of research going on, and uh, and the edge, intelligent edge, should definitely imbibe all the security measures from the cloud, or most of it. And so that should also help in the intelligent edge.
Sure. Thank you, sir. Next question is also from Dr. Srinivas. Sir, could you please elaborate on the kind of demands in device-to-device communication with heterogeneous devices talking to each other?
Well, many devices, I mean, devices like driverless cars, we are moving to a world where cars will be driverless and they have to communicate to each other. So a lot of technology is happening in vehicle to vehicle interactions, or even in smart factories, like when you have robots. Actually, there are already robots in the factory. So how do the robots interact with the different equipments? So that's again machine to machine interaction. In your home also, like if you have a smart refrigerator, that needs to communicate with your smart hazard system, fire hazard system, for avoid any potential hazard. So how do we manage this machine to machine? I think a lot of with 5G, they can communicate better, faster, and everything. And also, as I think a lot of the techniques that we use, like virtualization, containerization, developing co-processing methods, a lot of these technologies will help in managing heterogeneous assets better, in my opinion.
Yeah, thank you, sir. Next question is from Dr. Girisha. Sir, can you highlight on the research challenges in IoT?
Oh, tons of research challenges. I mean, all the technologies that I shared, whether it is IoT, AI, and 5G, they're at a nascent stage. I expect next 30 years, there will be a lot of evolution in technologies, whether it is silicon technologies, platform, software, networking, and how all these things interact. And also, right now we are at, I would say, we are probably at a 1% of mimicking the human brain. As I said, the human brain has 20, uh, 200 billion neurons with 32 trillion interconnections to give the kind of intelligence that the human has. We are nowhere close to that, and to get there, I mean, the amount of computation necessary, the amount of memory necessary is not a scalable problem right now. So that's why some research happening in neuromorphism. How do we closely match the human brain? Some research happening in quantum computing. I'm not an expert in that, but it's a new field that's being sponsored by Google and IBM to really, how do we make computation complexity much lower and solve some of the problems that your traditional computation cannot solve. So, and on top of this, lots of applications. I mean, applications everywhere, whether it is uh, healthcare, education, agriculture, you name any field. Lots of research happening there, and lots of research happening in the foundations. In whether it is radiation, I think all the questions came up, or security, or privacy, or ethics, or responsible artificial intelligence. How we behave responsibly with the artificial intelligence. Okay, how do we put emotions into robots? Many research happening, and next 30 years, our hands will be all be full.
Yeah, thank you, sir. Next question is from Lina. Now, from student side, they want to know what additional courses should the students do to become employable?
Well, I would say you all should, study well and do well in your exams and your courses, and follow your teachers and professors. That's the best way to succeed in life. Uh, Doing internship in good companies also helps you get that industry perspective. And uh, and I would say just be familiar with this artificial intelligence and communication technologies, right, which I'm pretty sure you maybe already be getting exposed to. Read material, papers, things like that will help. But nothing better than following your teachers, following your curriculum, and understanding the fundamentals well, and nothing better than that, I would say. Uh, this is a marathon. I've been 30 years and I'm still going. And it's a career is a marathon. So uh, you just keep doing well. Things will happen for you. You don't have to get very anxious or stressed out. This technology will evolve for next 30 years.
Yeah, thank you, sir. Next question is from Venkatesh. Which is the best protocol to use in IoT for home automation? It seems like the present standard is MQTT. So what are your thoughts on it? Are there any better protocols to consider?
I'm not very familiar with that. I think the maybe I should follow up. Uh, 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 but I would say, in a home automation, you have so many technologies, and they're all evolving. Whether it is your wireless protocols, cellular protocols like 4G, 5G. 5G will take some time to ramp up, or it's your Wi-Fi technologies. There's Wi-Fi 6 and other onwards. Then there is Bluetooth technology. So lots of technologies, and they're all making advances, and each of them has its own application or own usage in a smart home. And as I shared, this 5G, when it gets deployed very well, it will really achieve huge scale, not just a smart home, but taking smart home to a smart community, smart city. And again, our honorable Prime Minister a few years back, he announced 100 smart cities in India. So, and he's investing quite a bit on it. So, some of these technologies should help.
Next question is from Saurabh. Is there any reliable sensor in the market for presence detection? This is useful for safety in home and storage facilities.
Yeah, this whole computer vision, I can have a smart camera in my home and train it so that it can uh, potentially detect any intruders or any movement in my house. The biometric system, facial recognition, those are techniques also. To detect. I think multimodal learning, where you can, or multimodal AI, where you can superimpose image with sound, with text. Those techniques will also be useful for detecting any intruder, any unwanted events in your home. So that's also happening as we speak. Yeah.
Thank you, sir. Yeah, and I know there are several cameras from Intel itself, actually, for these models. Anyway,
Yeah.
So he has a further question, follow-up question. But
Yeah.
there are safety and privacy concerns in using cameras at home.
Yeah, definitely. There are definitely privacy concerns, and I think there are a lot of technologies coming up so that the data that is captured in your cameras, they are not distributed to the rest of the world, through different kind of encryption technologies. For example, I believe there is something called homomorphic encryption, which makes sure when you send data, they're encrypted and to the cloud or to the intelligent edge. And those intelligent edge and cloud, they cannot decode that. They have to process it in an encrypted state. That's one technique. The second technique that's coming up is federated learning, where if you have, let's say, 10 houses in a community, and each and they're trying to generate a common training model, but they don't have to share the training data. They share the model coefficients, weights, and things like that to the shared model. They maintain the privacy of their training data. So that's federated learning. So technologies are coming up to, yeah, but this is a big topic. Privacy is also a big topic that's being researched actively. See, a lot of this AI and neural network, the technologies are promises, and okay, but these technologies have side effects. How do we use it ethically? How are we responsible when you're using AI? I mean, when you are these days, people use AI techniques to scan resumes and call for interviews. But we just want to make sure that we don't form biases when we are scanning those resumes. So you have to be responsible when you're scanning the resume. So technologies have side effects, no doubt about it. And again, people do again research on those side effects and try to eliminate it or reduce it over time.
Sure. Thank you, sir. Next question is from Rishabh. He's worried about what are the opportunities in biomedical field in India, or do we have to go abroad?
Well, there are lots of wonderful biomedical companies in India doing lots of research. I mean, we're doing very active research in this COVID vaccine also. So wonderful companies, a lot in Bangalore. So it's not necessary to go in India. India is making a lot of advances in biomedical, and this AI should help in gene research, drug research, vaccine development, understanding interactions between different drugs and side effects, and um, the genes, figuring out which drugs could be better for a person or have side effects. So lots of things happening in this again. And I think drug development, drug discovery, vaccine developments will significantly get faster and with some of these AI techniques.
One more question from Dr. Prashant from GAT. Where do you position the MH Hector Internet Inside car in the current AI industry?
I'm sorry, I could not get the question.
Yeah, so I just read, so I was also not clear. So I'll read the question again. Where do you position the MH Hector? He has said Internet Inside car in the current AI industry. I think maybe he's talking about some particular model, MG Hector. Okay, he has clarified MG Hector.
Okay, I'm not familiar with this MG Hector. Maybe I should follow up. But cars, if you about cars are definitely going through major transformation in making making it more safe. ADAS, which is automated or driver assistance systems. Lots of technologies, whether it is radar technology, LIDAR technology, ultrasound technology, image processing technology, multiple technologies are along with sensors and neural networks are evolving to make this cars more safer and more autonomous. Again, it's a research field. There are different levels of safety, level 0 through level 5. I would say we have gone through probably more reliably to level 2 or 3. Still a lot more work needs to do happen. Level 5. Level 5 means basically it's a completely driverless car. All cars, any conditions, anywhere can be driverless. Still a lot more work to be done. But a lot of these technologies, as I said, different type of sensing and all this radar, LIDAR, ultrasound, multiple technologies coming up in this ADAS systems, automated driving systems.
Thanks. I have a question related to that. So you mentioned about partnership with IIIT Hyderabad, where interesting data set like Indian driving data set has come up. So any other data set which may be available in near future?
Well, I think a lot of it is on the research is on traffic conditions. The researchers is also how to bring in improved safety into our cars. So those things. Some things in healthcare. But it's evolving. I don't know the latest right now, what more they're doing. Maybe I'll find out, but those are the kind of things that we are collaborating.
Sure. Thank you, sir. That was the end of the questions here. So I would like to hand over to Dr. Srinivas and our Vice Chancellor, sir.
By the way, lots of good questions, excellent questions. I'm so pleased to see very candid and questions and thought-provoking questions. It's something for me also to take back and see what we can do better in Intel and in the India ecosystem as we develop these technologies. We talked about radiation, privacy, security, job losses, but many such wonderful things. Definitely thought-provoking.
Sure. Thank you, sir.
Yeah, thank you very much, Professor Sanjay Chitnis. Firstly, on behalf of Dayanand Sagar University, I heartily thank our guest today for providing an excellent industry perspective of the congruence of IoT, 5G, and AI, the importance of security in IoT systems, and especially protecting end user privacy, since the data is all pervasive, was beautifully brought out by Professor Sahu. It was interesting to hear that 70% of the devices in the world would be IoT enabled by 2025. In just 5 years' time, 70% of the devices. That calls for what is the kind of impact this field is going to have on the kind of research that is going to happen. And the pillars of 5G, throughput, latency and reliability, the pillars of 5G enabling all the technologies, it was beautifully brought out. The intelligent edge has to orchestrate between cloud and end devices, utilize technologies from various vendors efficiently, and the introduction of the fog computing and the federated and distributed computing has given lots of ideas for our students and faculty to work on the emerging industry, relevant technologies. DSU is extremely grateful to you for introducing our students and faculty to the demands of tomorrow. The Open Vino being developed by Intel, if there is a kind of student version of open source available, students would be very happy to experiment on this. Sir, in all, it was a very, very satisfying experience for us listening from you. And I'm sure we'll have many occasions to listen from you. I hand over to our Vice Chancellor, sir, for his closing remarks. Thank you so much.
Yeah. Thank you, Professor Srinivas. I take this opportunity to thank Sambit Sahu for taking time of his busy schedule to be with us and deliver this lecture, which is contextually relevant, because the current trends in the market have been brought out and very well explained. And I'm extremely happy that each and everyone could follow what you are talking, and it was on the dot. We immensely thank you for delivering this important lecture, that too the 20th anniversary of Bytes. I think it's a landmark kind of an event that's happened for Bytes. And we look forward to listening to you at a later point of time whenever you have some time. Probably we would invite you again to deliver lectures on a specific thing which Intel is working on. Probably that will also help the people to understand the kind of technologies that are going to come up in the future. Thank you very much. And also thank Ms. Sumit for facilitating this thing, and also thank the Intel team, your friends in the Intel team who are present in this particular meeting, also helped us to organize this lecture. Thank you very much.
Thank you for the opportunity, Professor Murthy, Professor Srinivas, Dr. Sanjay. Very much appreciate your help and support. It was a great pleasure. It's a great honor for me to come and share a few words with you on this memorable occasion, and congratulations on your 20-year anniversary. All the best, everybody. Thank you.
Thank you.
Thank you so much, sir. Thank you so much.